Well, to solve this question, we need to apply the fundamentals behind the concept of hybridization. Well, related to the hybridization, we have to find out the structure of these three molecules, right? Before doing that, just let me tell you something about hybridization. We know hybridization is a hypothetical concept. So, it is a hypothetical concept which relates to a reality, which is the structure or geometry of a molecule. Geometry can be proved by an evidence of the microscopic image of a particular molecule, but whether hybridization actually exists or not, it's a matter of debate, right? But when we go theoretically, we would first find out the hybridization and then try to correlate the structure of the molecule along with it. But technically, it should be the reverse. That means structure related to the hybridization. So structure should come first, then hybridization. But while we solve a problem, it should be the reverse. First hybridization, then the structure. So in order to find out the hybridization of a molecule, we have to apply a simple technique over here. For that, we need to first find out or identify the central atom. Now, how would you do that? Just to apply a trick, it will be the atom which is present alone. So, the atom which is present alone. In most of the cases, you would be able to solve or identify a particular central atom in a molecule by applying this trick or technique. Technically speaking, how would you ascertain an atom to be the central one? By looking at its size. The size of the atom must be the larger among all in a particular molecule. So the larger atom. Or if you have any confusion with the size, go by the electronegativity, the one which is less electronegative, or the one which is least electronegative among all the atoms present in a molecule. After one has ascertained the central atom, then this is a formula which he or she should be applying. Okay, this is a simple technique that I'm teaching you over here. You have to find out the value of H. This will help you to find out the hybridization of a molecule. For this, you need to calculate the number of valence electrons possessed by the central atom. So first and foremost, you need to find out or ascertain the central atom. Add to it the number of sigma bonds formed by the central atom once again. From that, subtract the number of pi bonds formed by the central atom, and lastly subtract the charge if present over the molecule along with the sign. That means if the charge is -2, so here you have to subtract -2, right? So this is a formula which you need to remember. It's quite helpful, which you would find very soon. You have to do this memorizing part. It's not that difficult. Okay. Now, after you have found out the value of H, what is the next thing that you need to do? Next, you need to once again you have to remember a few data. If the value of H comes 4 or 6 or 8 or 10 or 12 or 14. Now you would ask me, why not any value in between, or maybe less than 4, or maybe greater than 14? See, if you get any value in between 4 and 6, that means 5 or something like that, then it would not undergo, that molecule would not undergo any hybridization. So these are the values, possible values, that you would get or obtain after you apply this formula. If it is 4, then the hybridization is sp. If it is 6, the hybridization is sp2. If it is 8, it is sp3. If it is 10, then it is sp3d. If it is 12, then it is sp3d2. If it is 14, then sp3d3. Now, relating the hybridization to the structure of a molecule. Now, remember, when there is no lone pair. If lone pairs are present, then structural distortions will be there. Okay. So, we'll also discuss that what will happen in case of the presence of lone pair. If it is sp and without any lone pair, then the structure will be linear. For sp2, it is trigonal planar. For sp3, it is tetrahedral. For sp3d, it is tbp, trigonal bipyramidal. For sp3d2, it is octahedral. For sp3d3, it is pbp, pentagonal bipyramidal. Once again, I want to repeat myself that when there is no lone pairs, okay, when there is no lone pairs, then only these conventional structures would be obtained or would be adopted by the molecule. Okay. Now, how would you find out the number of lone pairs? For that, there is another formula. Okay. At first, you might find, or you might feel that a lot of formula, a lot of memorizing part is there, but it's quite very simple. One or two trials would make you very much comfortable with these. Okay. Right. So we'll quickly see how to find out the number of lone pairs. Okay. So to find out the number of lone pairs, once again we have to focus on the central atom. Number of valence electrons possessed by the central atom minus the charge over the molecule along with the sign, charge with sign. Subtract the summation of total number of sigma and pi bonds formed by the particular central atom. Now this whole value must be divided by 2. Okay. So let us apply these formula and technique to find out the structure and the first the hybridization, then the structure of these molecules which are given in the question. Let's do that. Starting with Br3 plus, which is the central atom over here. Consider this molecule to be like this. There is a central bromine atom and two terminal bromine atoms, right? And the entire molecule has a plus charge. So the bromine atom will be the central atom. So first do the calculation of H. How many valence electrons? Being a halogen family member, it would also possess 7 valence electrons. Then how many sigma bonds are formed? Normally halogens form sigma bonds, right? Only consider pi bonds for atoms like oxygen, nitrogen, sulfur when they are non-central atoms. Okay. So for the rest of the atoms, we would generally consider sigma bonds. Okay. So 2 sigma bonds with 2 other bromine atoms. No pi bonds, so 0, and there is a plus charge over the molecule. So this is 7 plus 2 minus 1, so that is 8. So the hybridization should be sp3. Now in case if there is no lone pair, then the structure will be tetrahedral, but in this case there would be lone pairs. Okay, so let us find out the number of lone pairs over here. So once again it will be the central atom's number of valence electrons, right? Then subtract the charge over the molecule and subtract the total number of sigma and pi bonds formed by it, whole divided by 2. So it is 7 minus 1 minus 2 divided by 2. So 7 minus 3 divided by 2, that is 4 by 2, that is 2 lone pairs are there, right? So this should be the molecular geometry where there would be a central bromine atom, and if it would have been a technically tetrahedral structure, this would have been the structure, but two bond pairs would be replaced by lone pairs. So let us consider ourselves that these are the lone pairs, okay, and there would be the rest two bromine atoms. Okay, so technically it should be a V-shaped structure or a bent structure, but none of the options over here are having that option. So technically if there would have been won't have been any lone pairs, it would have been tetrahedral, right? So we would stick to that because the options force us to go in that direction. So straight away option A and B goes out of the equation, right? Now let us see what will be the answer for Br3 minus. So it will be tetrahedral, so our answer would be either the option C or option D. Okay, now let's move to the second molecule, that is Br3 minus. Okay, so here it just would be doing certain changes, very small changes rather. Pretty similar to the last one, just instead of plus 1 charge, here you have a minus 1 charge, right? So right, so now it becomes 10, right? The calculation 7 plus 2, 7 due to the central atom possessing 7 valence electrons, 2 sigma bonds formed by it, no pi bond, and there is a minus 1 charge. Okay, so 10 means the hybridization is sp3d. Okay, and here there will be obviously some lone pairs. Okay, so 7 minus of minus 1 minus 2, so 7 plus 1 minus 2, that is 6 by 2, that is 3 lone pairs. Okay, now once again technically if it is sp3d, then the structure should be tbp, trigonal bipyramidal. So we can straight away select option number C to be the correct one. But before being very sure, or we would be sure, but let us see whether let us correlate this fact that the other molecule would have this geometry as given in the option, right? So let us try to solve question the molecule number 3, okay, which is Brf3, and it's a neutral molecule, right? So let's do that. For Brf3, what will be the central atom? Yes, bromine will be the central atom because it's present alone. Go by the size of bromine is greater than that of fluorine. Go by the electronegativity, the one which is less electronegative, right? So fluorine is more electronegative than boron, than bromine. We know down the group the electronegativity decreases. Fluorine, bromine. So that way you have to remember. Okay, fluorine, chlorine, bromine, iodine. So down the group the electronegativity decreases. So bromine will have less electronegative character than fluorine. So first try to do the calculations. Okay, no pi bond, no charge, so straight away it is 10. So once again the hybridization is sp3d. So if you calculate the number, though we are not according to the options, we don't have to consider the lone pairs, because they have given the options which the hybridization conventionally should have. The structure is given over here. So once again it will be PBP structure. Okay, number of lone pairs, how many it would be? There would be 2 lone pairs. Okay, so this would be the correct answer, number C. Okay, now let's solve another question.